Greetings, everyone, and thank you so much for joining us today. Today, we're going to be discussing audio solutions for effortless communications with a focus on corporate wireless microphones. Take it away, gentlemen.
All right, thank you, Cheryl, and thank you everybody for joining us this afternoon for us and somewhere in the morning for you guys, I think. We are going to be talking to you today about corporate wireless systems for use in your businesses. My name is Andrew Francis. I am the Applications Engineering Manager here at Shure UK, and I'm here with my colleague Tom.
Yep. Hey guys, you might have seen me on some other webinars. My name is Tom Coleman. I'm a Senior Applications Engineer here again at Shure UK, but covering mainly the indirect Western Europe market, doing all the vertical stuff really. So wireless mics and anything in between, basically.
Lovely. Well, today we are going to run through 4 topics on the agenda. First, we'll look at when are wireless microphones needed in your corporate environment, what the basic features of a system are, and then once we've learned the differences between them, what the process of selecting the correct system for your application might be.
Yeah, because I think it is quite a daunting topic. I remember before I worked at Shure, like you have to coordinate wireless frequencies. What? I thought you just turned a wireless microphone on and it just worked. And it's a continual topic of learning really for everybody.
It is, and the environment in which we can use them changes often too, which is another challenge to overcome, but we will talk about that as we go through.
Absolutely, absolutely. Yeah. So when might you need wireless? Well, we're focusing chiefly on the corporate world today, but there are a number of different environments where you may well need to use a wireless microphone. Of course, this image is beautifully demonstrating that this is like a keynote presentation. So the guys, I'm sure, delivering some sales reports or some financial information to a large group of people.
Yep. Secondarily here, we see a group of people on a video conference call. So this would be obviously necessary because the people in the room cannot communicate with the outside world without the assistance of a microphone of some sort. And we can make an assumption here that that is a very expensive table that they didn't want to drill holes into for static microphones. And the ceiling is incompatible with fixed microphones on the ceiling as well.
Or it could well be a multi-purpose space where they have to move the tables and stuff about.
Yeah.
Speaking of multi-purpose spaces, here we have an educational seminar room where the tables aren't on wheels necessarily, but are certainly move-aboutable, if that's a word. And we've got some gooseneck mics on the table, and the presenter or teacher is also talking into a handheld. So for remote learning or possibly audio-video capture for the session is also good there as well.
Excellent, yes. And finally, here we're looking at more of the business presentation. Maybe you're doing some media training, that kind of thing, where the lecturer needs to stand at the front of a hall and be picked up and reinforced to a larger group in a theatre-style environment.
And of course, because in those theatres, could be a local audience, as well as these days being broadcast and streamed to a much wider worldwide audience also.
Absolutely. And then a little bit of a similar scenario here where we've got a smaller group of people, each with their own microphone, doing lecture capture or remote learning or both at the same time.
Cool.
So I think the key message, the answer is, when do you need wireless? It's really when you need to communicate with people who are in your local room and too far away to hear you acoustically, or with remote participants elsewhere in the world.
Absolutely. Yep, definitely. So all wireless microphones are the same, right? Do they have the same characteristics? Or how might we choose them?
Well, yes, they are the same. They're built upon common components, but they are also differences within those areas too.
I suppose to clarify, the point of a wireless microphone is simply to capture some sound from one thing, transmit it magically across the air, and then basically get that audio out into the next device in the signal chain.
Yeah, so from a rock and roll point of view, you might have an SM58 on a cable going to a mixer. What the wireless system does is take away that cable between point A and point B.
Cool.
So if we break down the key components of our wireless system, we start with the microphone at the top, which is interchangeable. So we have different capsule types to have different sound characteristics and different frequency responses, that kind of thing. And that is connected directly to our transmitting device. So this is the bit that changes from a cable to a wireless bit. So instead of connecting that microphone capsule to a cable, we're connecting it to a wireless transmitter. Different form factors are available, but they essentially do the same job. We have the microphone here in the lavalier or headset plugged into a body pack.
But you still have a microphone and a transmitter.
Yep. It's just those two are now two separate components rather than being an integrated one. And then thirdly and fourthly, we have some table-based microphones.
I've got some here, haven't I?
Oh, yeah, let's have a look.
Oh, that's the body pack. There we go. So here's a gooseneck base. So this is the Microflex wireless gooseneck base. Again, does its job magically. This top section here is unsurprisingly the microphone, and you can use different lengths microphones to go in here to choose your particular application. And then that gets the audio into the gooseneck base, and you can transmit it across the airwaves like that. Equally, this is a boundary microphone, so typically designed to be placed on a surface directly. And you'd usually have your audience member, or if I was miking up Andrew, it'd be about there. So it picks up and usually a cardioid or an omni, so it's either directional or multi-directional, basically.
Yeah, so really 4 key transmitter types. You've got a body pack, a handheld, a gooseneck, and a boundary.
Yep.
So what happens after we've put audio into this transmitter? Where does it go? We need a receiver. And here we have a one-to-one relationship between our transmitter and our receiver, sending audio magically through the air. This is a one-channel wireless system. Now we often get the question, well, what if I've got 2 transmitters? How does that work? The first idea is, well, let's just grab another transmitter and transmit it on the same frequency, and then we can pick up 2 channels in our one receiver. Well, sadly, this doesn't work.
It's a bit like we're both in this room. Timo's controlling the system over there. If we both spoke different words at him, he's not going to be able to understand. Well, he's very smart, but there's a limit to even Timo's ability.
One or the other. So the way to fix this is we add a second receiver system, and now we've got 2 discrete channels of wireless.
Yep.
We are.
And we can build that up, really, can't we?
Yeah, we can scale this up. Here we are. Here's a third channel, so we're now doing 3 complete systems. And we can start, when we start building larger systems, we can start thinking about being a little more efficient with our receiver design.
Okay, so do we always have to use a single individual receiver to receive an audio channel?
No. If we scale this up into duals or quads, here we are. Here we have 1 receiving unit as a piece of hardware, but it has 4 receiving tuners in it. Therefore, we can transmit 4 channels.
Like 1 person with 4 sets of ears?
Yes.
That's weird.
Yep. And then we can scale this up even further to 8 microphones transmitting into 1 common receiver, either with the UHF band or with our DECT band, but we will cover a little more about that as we go along. Some ancillary devices here. All our microphones have the ability to have lithium-ion rechargeable batteries, which is very good for the predictability of use and also for the environment.
It's also a nice way to store the mic, as we've got in our base station over here.
Yeah, absolutely. So here we've got some different style charging stations, whether you want to house 2, 4, or 8 transmitters.
Gotcha.
And on top of this, because we are running digital modulation schemes between our transmitters and receivers, we can apply some proprietary AES 256 encryption.
Now, that might not sound like much, but it's quite key, isn't it? Because with an analog system, if someone was giving a large corporate presentation with some really quite special and hidden data in there, you wouldn't want anyone to snoop in. But yeah, you could with an analog system, if you knew what you were doing, find out which frequency they're transmitting on, use your rogue receiver and tune onto that same frequency and snip or snipe that audio from it. But with a digital system, both transmitter and receiver have to know the encryption key in order to decode the received audio.
Correct. So now we've had a look at which components make up a system. Let's try and understand how they operate magically in the air, invisibly around us, in the electromagnetic area of
there is a large degree of black magical wizardry or magic somehow how it all works. But let's have a look.
We'll try and break this down and make it understandable. So here we go.
Cool. So here is a typical office space. Lots of small rooms, lots of medium and larger size rooms in there as well. We're going to add some wireless microphones, specifically one in the center of the place. Cool. So that radio mic is transmitting on a frequency. It's emitting in all directions.
Energy.
That's right. It's radio. I was going to say radioactive. It's clearly not radioactive. It's radio frequency in all directions. And that will have a given footprint.
Yep.
Now, depending on the power level, or rather how loud the microphone is shouting, or the transmitter is shouting, I should be particular, that footprint might be smaller or larger on a given day.
Yep.
Now, if we add a second microphone to this, we're also going to have a second footprint. That's also going to take up some real estate or space as well. So the way that
overlap.
Exactly. So the way that Andrew is standing here, that physical space is taken up by him, which is why I have to stand a given distance away. And it's a similar topic with wireless microphones also. So there's two. We can easily add a third one in as well. So you can see it starts to get really quite busy. That's just on one small floor of a building, but how might it manifest on a larger scale? Here we have a shot of the city here in London, and we can imagine we have one radio microphone being used at the top of that building, which I should remember the name of, but I can't. So we can have that one microphone has plenty of space to operate there, no problem.
I know this one, the next one. That's the gherkin.
Cool. Why is it called a gherkin?
Because it looked like a gherkin.
Gotcha. There's the second one, taking up, again, its own bubble of space, no problem. So think of it like a sphere of sound, if you like. And more and more bubbles and spheres can be added with no problem. But as you start to add more and more in, it can really start to get somewhat congested. And this is when it becomes a problem and possibly a challenge, which is a big topic for possibly another day. But we're going to give you a brief interim just right now. Introduction, that's the word.
Yeah, so the invisible area that these energy radiates into is called spectrum. So here we can see we have a lot of devices taking up a lot of spectrum, and there is a lot of overlap and potentially interference between them. So let's have a little look at what this invisible spectrum actually is. Well, it's part of the electromagnetic spectrum. So on one end, you're going to have microwaves. On the other end, you're going to have light waves. And somewhere in the middle, we've got, is that right?
Yeah, and
somewhere in the middle,
just to reiterate, visible light is a form of radio wave, just to run at a very high frequency, much higher than the radio mics we use. So we can see some of this electromagnetic spectrum. So radio mics use a similar thing.
Cool. And it is finite, which means that governments can apply some regulation to its use.
But it also means that each chunk of spectrum can only be used by one thing in any one space. Like you are standing there right now, but if you move from that spot, that space is still there.
And I could come back to it, or you could move into it.
Correct. And it's a similar thing with radio mics and their frequencies.
Yes. So this is the operating bands that we can use in the UK. So down at the lower end, we've got VHF transmission at 100 megahertz. And then all the way at the other end, we've got our Wi-Fi at 5 gigahertz or 5,000 megahertz.
And all those white gaps between the grey blocks?
They're still there and available to use, but they are reserved for other services.
Okay.
That might be chiefly television broadcast and device-to-device communication.
Radar and all sorts of stuff. Gotcha.
That kind of thing. So for our discussion today, we are limiting our spectrum usage to the UHF band in the middle, which is chiefly like the midway through the 400s to the upper end of the 600s, and the decked band, which is our 1800 megahertz bit.
Both are acronyms for stuff, but we're not going to worry about that just today.
And whilst now we know which area of the spectrum we're using, and we know that local governments can apply regulation to their use, it's a good topic to move on to the licensing.
It is indeed. It is indeed. So let's have a look at some of the licenses that go on. What you'll find is that most countries have some regulations. Some countries are more lax with them. Other countries are more particular about how you use the radio frequencies, which ones you can use and how many you can use and all that kind of thing. Yeah, precisely. But we're going to use a couple of examples from the UK, which I think is, from my experience, one of the more stricter areas. A quick look at the US, but that we can't cover the whole world because there's too much for everyone to remember. Here we go. So there are three key channels to look at here. The first one is what we call in the UK TV channel 70, or specifically 863 to 865 megahertz, a small little chunk. You can use those for baby monitors, small karaoke wireless microphones, singer-songwriters. It's a small chunk, but usable. And
it's essentially in the UK unregulated.
That's correct.
Anybody can use it for any purpose.
Which is great. But the bad side is anyone can also use it for anything. So the other one we have is decked there. So decked is that's the global band, so 1.88 to 1.93 gigahertz. And varying countries will use subsections of that across the globe.
And mostly that's for headsets when you're in a telephone scenario.
Yeah, and the MX wireless system we have here.
Microphone wireless, that kind of thing. Yep.
And the last band we have there is our well-known Wi-Fi. So it's a digital protocol that gets used in that very specific band there. So all the Wi-Fi you know, and we can also stick some wireless mics in there. Each band has its own pros and cons. They have their,
We wouldn't typically recommend the use of the Wi-Fi band for microphones because most businesses are happily using that for their computer networking.
Yeah, that's true. But you can get some in there, and in the right application, it's great to go for.
Yes.
So the ones that are free to use in the UK, the licensable ones, I'm not going to read all this out, but basically you can have a dedicated TV channel for low key, if you will, or professional users rather, and you can rent that out for a year or 2 years. And you can also use the interleave spectrum, which is the UHF band where TV transmission is not happening, and you can rent that out per frequency or per TV channel, per year or per frequency, or per day rather.
Yeah, so in my experience, a business who's located in central London who wants to operate 20 microphones within the UHF band will apply to the licensing body to use an 8 megahertz chunk on their postcode for their year.
Gotcha. So they've logged their usage of that on a database somewhere, so other users can't try to license the same thing.
Yeah.
Cool. So that's a similar thing. Let's have a quick look at how it works in the US. In my experience of this, it's chiefly free to use for UHF users. However, if you are a professional user, i.e. Like a sound hire company doing events in stadiums and gigs and tours with...
Making money from the use of the kit.
Yeah, exactly. So typically over like 50 channels of wireless or so, you can apply to be a licensed user, which means a couple of things. You can use a higher power. Higher power means you're shouting louder with the microphone, so you can do a further transmission distance. And lastly, you can use some extended bands beyond the regular stuff that most people are permitted to use. So a similar theme to the UK, but a bit different, basically.
Excellent. So now knowing that we have a choice of transmitter type and a choice of spectrum type, how are we going to choose?
Just roll a dice.
Yep. Let's have a look at this in a little bit more detail. We think there are 4 key topics to consider when making a choice of radio microphone to use, and we will break that down into some small areas. So
they call it a decision tree, don't they?
Decision tree, here we are.
So here we are at the top of our decision tree, wireless microphones. Excuse me, there's 4 topics here: channel count, usage, application, and lastly, transmitter type. Will pretty much narrow down your search to one definitive type of wireless mic, or possibly 2, which you can then make an informed decision on.
Yes.
So the first one, channel count. So we've got simultaneous usage, total number, proximity, and existing wireless. So let's break those down. You need to consider really how many rooms you need wireless in and how many channels in each room could be used at any one time. Yep. You might find you've got a bunch of rooms but only one channel is being used at once, which means, back to our little spectrum of radio mics on the London city, you could get away with more than you arguably could use in one particular area. But it's best really to consider this is the maximum I would need at any one possible time. So that's a factor to consider. Total number, do I need all of these on at any one time, or can I use subsets at one particular moment? Proximity, how close are the rooms next to each other? So Andrew could be shouting on one frequency, but if I'm spaced, off camera somewhere over here, I could feasibly share that same bit of actual spectrum by being socially distanced.
Yeah, I mean, it could be it could be that you can use the same frequencies with one set of microphones in the basement and the other set of microphones on the 20th floor.
Or even the same frequency in multiple cities, because it doesn't transmit that far. Lastly, you need to consider what else is there. Often there might be other people using wireless stuff on site already who are using those physical bits of spectrum, and that can have a knock-on effect as to what's permitted for you to use. Yeah,
back to our tower block building scenario, there could very feasibly be 2 businesses, 1 floor apart, both using 50 radio mics each.
Yep.
And there you need to take a lot of care over which system you choose in that scenario, because you might think you're only buying 20 systems, but you have to fit in with 20 others. The next topic of discussion is usage. How do you imagine that your users of these devices will interact with them? So self-service, can the user be expected to walk into a room, pick up a radio microphone, and it just work? I think that's very good. I think that's gold standard, really.
Just what we'd hope or expect,
Is it a managed space? So do you have a facilities manager or an AV services team who will deploy radio mics out to other business users as and when required? Or are they remotely managed? So do you have infrastructure in your building that you want to be able to log into and maybe do some remote pairing and some remote linking, or just see
if anyone's stolen anything.
If anyone's stolen them, have they gone out of usage?
Or
yes.
if the batteries are on charge.
Any good metrics there? Yes, right. Decision point 3.
Absolutely. So let's look at the application. So the first one is flexible space. So think about the meeting types and the room configuration. Do you need to have multiple tables all over the place to do their thing, and whether that would work and be a normal way of doing things? It could well be a training room, which again could be a collaborative or lecture theatre type thing. If it's collaborative, you're more likely to have goosenecks and boundaries placed on the table so people can more naturally converse with each other.
Yeah.
But if it's a lecture, it's going to be more of a, I am talking to you and addressing you through a very clear microphone right now.
Yes.
So there's different kind of conversational styles versus formal styles as well. We also need to consider how many mics we might need per person. So we've got the 2 boundaries here. Andrew and I could well have one each of these if we were far enough apart, or depending on budgets and the size of room, you might be able to get away with one between 2.
Yeah.
That would be okay. And the last point is mission critical. This is the board member, CEO, broadcast room. This is the mic going out to the big room of local people as well as multiple sites worldwide as well. It's like, you want to make sure that mic is going to work. And while we are super happy and confident at how we make great stuff, do you know what? Life happens sometimes.
Yeah. Yes, if you accept that a failure might happen, who is it most going to impact? And who should you mitigate that
and
risk
if it's the
most
tech,
for?
it's like, what can we put in place to make certain that if something does happen, it's masked?
Yes. And then finally, we've already touched upon this, but what type of transmitter do you require? A handheld for holding in your hand and walking around. Benefits are it's very quick and easy, but the negatives to it is that if you have to hold it, you get a lot of differences in the sound quality when you move it around from the sound source. So in that scenario, maybe a headset lapel mic, as we're wearing here, would be more appropriate. I think I would find presenting this with a handheld mic quite annoying, so we've opted for the lapel. And then the table-based options of your boundary or your gooseneck. Well, there we go, some bullet points to reiterate my point. There we are.
I always find it satisfying when the bullet points say what you just said.
Yes.
Yes.
Proves I've done my homework.
Right, what's next? So there's our big chart, there's our huge decision tree. So if you give a little bit of thought to each of these considerations, it will gently err you toward one of the particular microphone systems that would work well for you.
Excellent.
Go on.
So now we have an idea of what system I need. Now we have to think about the spectrum bit. Is it?
Indeed.
I think I want to use this product, but I need to be sure before I invest some financials into it.
And we will go through the products in some detail in a few minutes.
Yeah.
So we need to think about the spectrum. How much actual space is there for the mics to operate? So how busy is the spectrum there? Will I have space to operate, of course? And how many channels might I be able to get there? Because it could be, I'm going to use some of that band, but I need to get more than that. So I'm going to have to use UHF and DECT, for example. And was there stuff from outside that could start to interfere with me in my building?
Yeah, and that could be any number of things. It could be a security team who are using radios.
Yeah, no, I think to put it in place, we were suggesting there's a bit of doom and gloom with this, but actually there are tools in place to make sure that with a bit of planning, you should be pretty good to go.
Absolutely.
I think planning is always key.
Yes.
So let's have a look at this UHF band, the old 470 to 694. Again, the bands differ a little bit from Europe to the US, but we'll cover that in just a second. So this is a big, giant chunk of spectrum, like a lot of real estate, really, if you will. And we split it into chunks. They're usually between 6 to 8 megahertz wide or so, and these are the so-called TV channels. They used to be analog TV channels broadcast in a single one, but now the digital ones can do multiples in what we call a multiplex. And each of those chunks is assigned a particular channel number. So 470 to 694 in Europe chiefly looks like this when broken down. So 470 on the top left is called TV channel 21, and you can see it's 8 megahertz wide with TV channel 22 going 478 to 486. I'm not going to read it all out, do not worry. But you can see it's contiguous spectrum rolling from 470 up to 694 and have channel numbers assigned. So consider the UHF band, if you like, to be a car park. And that car park has been divided into a bunch of 8 megahertz TV channels, and that would be a space or an area in that car park. The US model is pretty similar as well. If you look at TV channel 21 here, it starts at 470 and goes up to 478 and is number 21. Here's the US one. Also starts at 470 but goes up to only 476. And here is called TV channel 14. So they're unaligned, but it's a similar kind of concept.
Yep.
Here we have the UHF band, again, still a car park or parking lot this time, of course, but we're just splitting it up into these 6 megahertz TV channels. So your radio mics can operate in some of these TV channels, and different radio mic systems can cover, say, 6 or 7 of these channels, or some can cover way more. So depending, you need to figure out which of these so-called TV channels is available where you are.
And this comes into the price point of a system, because we're looking at the idea of efficiency. So an inefficient system could be the idea of one large vehicle taking up that whole car parking space.
Yep.
Or maybe you have 2 smaller cars that you could park sideways and fit in, or maybe you could get 4 motorcycles and so on and so forth.
It's like packing the van after a gig. You put the big stuff in first and then fit the little things in around it, as opposed to just put the big thing in the middle of the bay. So let's have a look at some different ways you can find out which TV channel you can use. It's a bit like the licensing. We've got 3 different countries, for example, here, and you'll see a common-ish theme between them. Here is the US one. This is on our website, actually called the Wireless Frequency Finder. All you do is tap in a postcode or a location as your zip code, I should say. We call them postcodes here. Nominate which system you're going to use. I've chosen ULXD in this instance, and hit the bright ignition green search button. Then what happens is it shows you the various bands that are available in that location. Here are 2 of them that are available, both band G50 and also J50A.
So to be clear, G50 is a Shure nominated frequency band of product.
Yes, that's correct, and refers
not
literally
a TV band. It's
correct.
A group of TV channels.
Thank you for clarifying that. And it basically refers to the range of frequencies which it covers. You can see on there. I can't read it.
So group 20 is, it's even smaller
that's
down
really
here.
Small. Anyway, the point is that band G50 would be the one to go for, because it can house up to 27 systems across its tuning bandwidth, whereas J50 by comparison can only cover 5 channels or so. The reason for that is this: because of which TV channels are available and equally unavailable. So clearly the available TV channels suit that first band and don't really suit that second band.
Because we are, as radio mic users, trying to avoid the broadcasts of the actual TV broadcasters.
Yeah, of course. Everyone needs their same physical space. If there was a cactus or something, or an old shoes on the floor there, it's like that becomes interference. Like, actually, I'd like to have my own clean space in which to operate, so everyone can do their thing properly.
Yeah, and rightly so. TV is more preferential than radio mic users.
Particularly to the TV station, yes. So that's how we do it in the US. Here's an example from the UK, a similar but different system. Here we use our spectrum regulator called Ofcom, Office of Communications. Similar thing, you tap in the location, choose which location you want to use, hit this search and find button. It will give you a chart that looks a bit engineering, but a bit like this, basically.
Very useful, though.
It is, I agree. So the 3 columns: TV channel, internal frequencies and quality, and lastly, external frequencies. So the first thing to mention is, if we're using radio mics inside, we're more likely to be able to use more spectrum, because the TV station's broadcasting stuff outside is going to be a stronger signal outside the building than inside the building, because the building will act as a shield or blocking that sound. It's a bit like it's raining outside, but the rain doesn't get indoors because we're protected from it in here. So you're going to get wetter outside than you do indoors, unless you're going to swim pool. Anyway, so you'll always see a better selection of frequencies available to you inside than outside. So here,
as most corporate use is inside, I'd suggest we want to be looking at this middle column.
Correct.
Unless you're doing a garden party.
Yeah. So you can see how the higher number TV channels generally give you some pretty good broadcast areas in this particular area. However, as you go toward the lower ends, the 470s of this world, the spectrum becomes less available, because we know there is some TV transmission in London there. And lastly, just to give a flavour of La France, it's a similar page, again showing you that the TV channels on that column, that row rather, from left to right, showing the various varying strength levels of the TV broadcasts in those areas.
Yes. So that's one way of checking, broadly speaking, what should be available.
Good word, should. Yeah.
But nothing really, nothing is a good substitute for actually checking for yourself. So we need to do, or somebody needs to do, a spectrum scan.
We'll go and have a look.
It's basically like a site survey, isn't it? You wouldn't go and expect to build a sandcastle somewhere where there's no sand.
That's true.
So you have to go and check and see that the resources that you're looking for are actually there before you do it. So how are we going to do this? Well, very easily, you can do it yourself if you are in possession of a Shure wireless receiver with a network connector on the back. In absence of one of those, you can ask a Shure authorized dealer or integrator or distributor. And if none of those are available, there are a number of third-party professional RF coordinators out there who, on a freelance basis, I'm sure would come and do this work for you.
Absolutely, absolutely. Well, let's have a quick look at how we can do it.
Yeah.
I've got two systems here. I've got a ULXD system behind me to my left, and also the MX wireless system split in multiple areas.
We've got these two because they use different spectrum types.
That's right. So the UHF system uses DECT. No, that's wrong. The ULXD system uses UHF, and the MX wireless system uses the DECT band, so the one up in the 1.8 gigahertz area.
Happily use both at the same time because they are usage far enough away from each other that they don't cause each other interference.
That's correct. That is correct. Right, let's have a look. Timo's the right thing up for us. Cool, right. So this is my laptop, as you can see. I remember how to use it. I'm going to open a program called Wireless Workbench. Wireless Workbench allows me to set up my kit, do some scans, do some configurations. It's used by a lot of the corporate areas, but it's also used chiefly by the professional sound engineering people who do like huge, big gigs and shows. But this isn't a workbench tutorial. So here are my 6 receivers. I've got a dual and a quad, so a total of 2 plus 4, so 6 channels available to me. But I'm most interested in this page here, the frequency coordination page, how to coordinate or choose my frequencies. This is my scan window, and as you can see, there's nothing in it apart from these 2 horizontal lines at the moment. Let's populate this with some information to show how noisy or how loud the RF energy is in this room right here, right now. So I'm going to grab my ULXD quad and nominate, I would like to use, why not, channel 2 of the receiver. And I'm going to start the scan. Here we go in 3, 2, 1, go. There we go. So
what this is doing now is monitoring its electromagnetic spectrum surroundings and plotting it for you.
Yeah, it's a bit like me standing here. It's like, yep, there's nothing here.
Yeah.
There's nothing here. You get the idea. So you can see it's just done UK TV channel 38, and you can see it's got mine and Andrew's wireless mics because we're in TV channel 38, so that'll be us right now. But the rest of it is looking pretty quiet at the moment, but we'll come back to that in a second. Let's crack on with the MX wireless mic. Yeah, I'll leave that going in the background. Ooh, new desktop. So I'm going to go to the Microflex wireless app. This is a new app we got a few months ago to connect to our MX wireless systems. Okay, this won't be a full tutorial on the kit. There we go, the APT is shown. APT stands for Access Point Transceiver. It's the brains of the whole system. So I'm going to open this guy up and hopefully remember my password.
Same as your bank account.
Yep, 1, 2, 3, 4, 5. There we go. So this is my APT. You can see we've got these 7 microphones linked to it at present, and they're all happily charging. But what I'm interested in right now is this button over here, the Spectrum Scanner. This does a scan in a different way to the ULXD. ULXD is sequential, this one, then this one, then this one. But the DECT thing looks at all frequencies in all time slots.
All the time.
Basically all the time. So we're going to look at 2 things. Firstly, the current spectrum, what's available to me or the MX wireless system in this room literally now, and also the minimum spectrum, like over the last 24 hours of scanning, from when you press start, what was the worst case scenario? Because you might find that, cool, I did my scan for 3 minutes and it was all good. However, the guys next door have a bunch of telecommunications microphones or little headset mics for the comm system, and they didn't turn on till 4 in the afternoon. And oh no, suddenly you've got
exactly when you're going to do your corporate presentation.
Yes, Sod's Law would say. Right, so let's have a quick go with this. I'm going to hit start scan, and then here we go, 3, 2, 1, go. And what you'll see on the device is the little LEDs are now flashing to nominate I'm doing a scan at present. So you can see on this window here, at the present moment, we can get about 56 or 58 channels on air in its standard mode. Oh, it's gone up a little bit, look, but it's still used the minimum. So the minimum would never go any higher than that.
Yep.
But the minimum would only go a smidge down depending on what interference it saw over the day.
And this is in our room here right now. So we could stack this area with 60.
Well, 56, 58.
Yeah, okay. Transmitters.
Yep.
Then we could leave this as an operational system and then go and take a receiver elsewhere and see if we could get any more elsewhere.
Yeah, about 30 or 50 meters away and repeat that whole process again.
Yeah.
Exactly. Cool. Right, I'm going to end that scan because we don't need to do that anymore. And let's go and see what the ULXD is doing again. So the ULXD has finished its scan and we can see it's an absolutely super low noise floor because basically we're in the middle of nowhere. So
in a building.
Yeah, yeah. So we're pretty well shielded and there's nothing really much going on here. So that's a good clean spectrum scan. But we've got some other scans to show, haven't we?
Yes. So if you were not quite as lucky, you might see this green type scan here where we've got one radio mic transmitter poking above the noise floor there.
Like some digital TV down the bottom left-hand side.
Yeah, and this was used using a wideband scanning device. So it's scanning right up in the 900 megahertz range there, which our ULXD isn't transmitting on, but it's good to see what's around.
Yep.
If you were less lucky, you might find something looking like this. So here you can clearly see there is a lot of devices using the whole UHF spectrum. And those very square looking blocks, those are the very high power TV transmissions. And so now we need to be a little more, or rather a lot more selective over where we place our radio mic frequencies.
Not impossible, but
no, certainly not impossible. But I think this very nicely proves the point that you can't just turn it on and hope it's going to work.
Well, you can hope it's going to work, but it's not necessarily going to work.
No, maybe not. So you've done your scans, you've seen good noise floor and bad noise floor, and it again is informing you with some actual proper data over which systems you should be choosing. So let's look at some product now. DECT-based, you showed us this with the access point and the very nicely docked in the network charger there. Microflex wireless, which is very, very common in the corporate environment.
In this region.
Yes, okay, yes, that's fair. Moving on from there, we can move to the UHF bands, ULXD, and then if you are working in a very UHF hostile environment, very congested, you might need to consider Accent Digital or some of the other redundancy features for your mission critical applications.
Yeah,
so
absolutely.
Shall I take MXW?
You go for this one.
Yeah, all right, cool. So Microflex Wireless is built to transceive in the DECT band, which is the 1880 to 1900 megahertz. I think that's specific to the UK.
That's correct, because it goes up to 1930 across the globe, and it's different subsets of that that operate in different areas.
Yep. This is designed for conference-minded applications. So we don't typically recommend Microflex Wireless for reinforcement, but it can be used for it in certain situations. It is very end user friendly. So this is the system if you want to pick it up off the charging station and it's just going to turn on and work. Microflex Wireless is the one for you. And we say this as well because you don't need to do the frequency coordination in the same way that you do with the UHF. It will work it out for you. If it finds interference, it will choose another channel for you under its self-managed wireless thing. So we've then got our advanced remote management tool, which is System On. And you can see here, we can very easily in our location stack 50, 60 mics in one go, which we would consider a high channel count. And we can get even more than that if we put it into high density mode.
Because the reason high density mode came out is because the US's DECT portion is precisely half of what we have in Europe. So their equivalent of their 56 would have been sort of 25, 30 or so. It's like, so that HD mode came out to really extend their ability, which massively benefited us, of course.
Absolutely. In the transceivers, we've got 2, 4, and 8 channel options. So you've got choice. It's not, you don't have to buy an 8-channel one when you only want to deploy 2 microphones.
You can stack multiples of those side by side to form larger systems.
Yep. If you needed 12 channels, you could buy an 8 and a 4 and run them at the same time. And the access points are clever enough to know that they're both on air at the same time and they can manage their wirelessly collectively across the 2 access points. Because it's a digital transmission, it's encrypted. And let's have a look at some of the components. So Tom, what we've got over there?
Well, Yep, the first one is the MXW1 body pack. As you were saying yesterday, you'll find a common theme with the numbering of these.
Yes.
The MXW will always tell you the system type, but the one component will always be a body pack.
Yep.
So therefore, the two components is always going to be a handheld. So this is the MXW2, again with the interchangeable capsule. So I can take this head off right now and we can swap that for a different one depending on the sonic quality of the audio you wanted.
Everybody loves an SM58, but I tend to prefer the SM86 for corporate
good for your vocals. Gotcha.
Yes, much better for me.
Cool, what's the next one?
A 6.
That's the boundary, the one that sits directly on the table like this. That's always the 6 component.
Yep. And following on from that, we've got the gooseneck.
Cool, and lastly, this one will unscrew, like I said a second ago, and you can swap that gooseneck part out for a different one. And again, different polar patterns in the actual gooseneck top.
Lots of flexibility. So all these will talk over the DECT band wirelessly to the access point receiver in your 2, 4 or 8 channel variant. And then we handily have 2, 4 and 8 channel variants of the network chargers too. And finally, as a component to tie it all together and into your Dante-based DSP, you're going to need a network switch.
It's probably worth mentioning that this was the first system we had about 8, 9 years ago that was what we call application driven. We really looked at how do people use wireless microphones in a corporate setting rather than we'll make rock and roll microphones and try and drag some of them into the corporate setting. How do people in the corporate area use it to really maximize the use of spectrum in that area? And that's why all this is networked and automatic
and license free.
Correct.
Yeah.
Correct. There's also one cool thing, because normally you would have, say, an 8-channel system with an 8-channel network charging station with 8 transmitters on in a room to be used together all the time. But sometimes you don't want to do that because you don't want to have these devices in the room. Perhaps you've got no credenzas to place them on. You just want it to all look neat and tidy. Here we have our famous wireless building from earlier on in the presentation, and we are going to install 4 MX Wireless APTs within the system over here. But we're not going to put the network charging station in those rooms. That'll be placed at reception over here. So the receptionist can have under their desk a heap of transmitters, and say that large room in the middle wants to have a pair of transmitters used in there. Cool. Stick them in the charger, press some buttons on a control panel, and you'll be able to link those devices automatically to that middle room.
Yeah, so that means they're on, they're transmitting, and when the person who's done that handover process with the receptionist, they wander off, and as soon as they get within range of that access point, it works.
Cool. And secondly, you can have a similar pair of transmitters that get deployed to a different room as well. So it's super easy to use. You've got a good point on this in terms of amount of kit you have on site.
Yes, absolutely. So you may find that you don't need to fully populate all the rooms with all the transmitters all the time. So therefore, some cost saving could be had by purchasing a smaller number of transmitters and deploying them in this remote linking scenario. And then if you find that you're running out regularly, you can make further investment rather than investing in loads up front.
So ability to receive in each room in full, but then the actual transmission element, you can just, we tend to find that the handhelds are popular, or people really like the goosenecks. Let's get 6 more of them.
Yeah.
Cool. So let's have a look at some, oops, we both pressed the button at the same time. I'll go back. Let's have a look at the DECT system. So I'll go through the positives because I'm Mr. Positive. It is license exempt globally. Again, different bands in different regions. It's also worth mentioning that DECT is typically not available in the far east of the world, which is why I said earlier it's not fully global, but that's where ULXD with its goosenecks and boundaries come in. More on that in a second. Andrew mentioned it's got the automatic coordination as well as the avoidance of interference, and pretty large channel counts as well, which is awesome. And
with positives always come negatives. So data compression, we say this compared to a UHF system, we are compressing the data a little bit. The channel count is dependent on the codec. So what that means is there is an upper limit on how many we can transmit.
Physically getting anyone going. Yeah,
absolutely. There is, again, compared to the UHF system, added latency in the way that the modulation scheme happens, and it has to wait for a time slot. It's still very, very short. It's like, 14, 15 milliseconds. But in certain scenarios, that's just enough.
This is where it comes back to that application-driven wireless. With pro rock and roll stuff, that latency for in-ear monitoring has to be super, super low.
So low,
But you know what? For a video conference, which is going to be a delay of a second from end to end anyway, 14 or 15 milliseconds of delay is not a problem, but it also permits the super clever channel sharing, channel hopping as well. So it's an appropriate amount of latency for the system.
You do need to share the DECT band with other telephony units, i.e. DECT phones. And again, compared to UHF, its operating range is short, but we're talking about 30 meters. That's still quite far.
Yeah, that's a big boardroom. If your boardroom's got your receiver on, well, we've got a Wi-Fi point just up there, for example, but if your receiver's on the wall, your room might be 8 by 4 meters or something similar to that. It's like, that's not a great distance to transmit.
I would like to add one more negative to this.
Oh no.
I would not recommend a DECT-based system for a town hall scenario where you're putting a large audience in the same space, because the DECT range tends to suffer more absorption when you put big sacks of water in the way.
That's because it's at a higher frequency, and in a similar way to the way sound waves, it's easier. Like when you go outside the club, well, I used to go clubbing years ago, reluctantly, but when you shut the door on the club, all you hear outside is the because those higher frequencies have it's much easier to stop them basically, and it's a similar thing with higher radio waves.
Yeah, sadly we have had some customers who've used a DECT-based system in a auditoria, and then it works during testing when there's no people there, but as soon as all the audience arrives, it starts to suffer a little bit.
What's next?
ULXD.
Cool. So I'll go for this one. So this is again a UHF system, as we've mentioned already. So it's designed for, again, medium and large room usage, and not really designed for the small, oops, drop the clicker.
You can use it.
Yeah, you can use it, but it's not optimized for that really, in the same way as you can use the MXW for those small rooms as well. It features, like the other system, Dante digital audio, so that can go straight into many audio DSPs straight away for you. It is, again, super easy to use, a bit more involved than an MXW system. It requires a coordinatory effort.
It's more involved in the setup, but once it's been set up, it's easy to use. Yeah.
You can also remote monitor it using the same network infrastructure and software tools. It also has a very high channel count, and as well as its standard definition area, a high density area where you can really, really stack those transmitters super close to each other. It requires a very steady spectral environment around it, but can definitely be done. It, of course, is encrypted, being a digital wireless system. And here are the components. These will look familiar. I'm going to click, you can talk.
All right, so first up, we've got the ULXD1 body pack.
We're using today.
Yep.
Sounds great to me.
Yep. ULXD2 handheld, same thing, interchangeable capsules, SM86 for corporate use. We like it, we like it. Well, actually, KSM8 here would be the money shot. ULXD6 boundaries, where you've got cardioids and omnidirectionals, and ULXD goosenecks, and all the interchangeable bits for the MXW and the ULXD systems are the same. You're going to need a receiver. Here we've got 3 receiver types. We've got a single, a dual, and a quad. For stacking systems together, I will point out at this stage that the single channel receiver does not have a Dante chip in it.
But the others do.
The others absolutely do. And we've got various charging stations for all of them. Actually, the pictures here only show the W-shaped ones for the boundaries.
Which I've got on the rack just behind me up here.
But we do have some stand-up ones for the 1s and the 2s as well.
That's right. Cool. And last but not least.
Yeah, let's go to the top of the tree. Whoop. Axion Digital. So if you're in an area where ULXD isn't going to fit your needs and you need something that's that extra little bit capable, then Axion Digital is absolutely your friend. It's designed for the mission critical applications. So this will be your CEO on stage broadcasting to Bloomberg News with a wireless mic, and if they drop out, this is going to be bad news.
Yeah, it's worth mentioning this is the go-to system for what we call the pro area, so the ones doing all the rock and roll festivals, the Grammys, the Brits, lots of West End theatre shows, and Broadway all use Axion Digital.
Yep. It's got the widest tuning bandwidth, which we'll cover in a little more detail in a moment, but broadly speaking, if you want to use the whole range that Axion Digital has, you have to have 3 different SKU points for ULXD to cover the same range.
Gotcha.
We can do coordinated automatic backup frequencies. So if the frequency that you're transmitting on becomes compromised, the system can monitor that and remotely send it a new one, which means you won't suffer any kind of loss of transmission. We can do remote monitoring and control. Very, very high channel count with Axion Digital. It's encrypted because it's digital, and for all these reasons, we consider it the premium grade digital wireless system. And it has more outputs for connecting to more systems. So we've got analog outs, all the type of digitals, and so on and so forth. And latency, it is the lowest of all our products, extremely low at 2 milliseconds.
Significantly lower than MX Wireless, but again, given that this is designed for that pro rock and roll area, there's a reason why it's so low.
Yeah. Component-wise, we're going to rush through these because it's a theme. We've got the AD1 body pack, the 2 handheld, the 4 receivers, duals and quads only here, and then the connectivity is common across both. Rack-based chargers. We will point out there's no goosenecks or boundaries for Axiom.
That's true. That's one of those kind of decision tree things. Like if you want goosenecks and boundaries, Axiom Digital is not a system you can choose here.
And then when we can start taking some advantages of this very clever remote control and monitoring of the wireless spectrum that the transmitters are using, we rely on the Spectrum Manager in conjunction with the ShowLink controller, which is a secondary wireless link to the very special and very clever ADX transmitters.
They're the ones that can be remote controlled, so avoiding frequencies, interference as and when you need them.
Yep, so it's a modular system that you could invest in 4 channels of regular AD1s and 2s, and then 2 channels of ADX for when you've got the very special people who can't afford any kind of wireless compromises.
Gotcha.
And I think we covered most of these in that last little
I think you did actually.
To just rush over them, wider tuning bandwidth, 184 megs versus 64 compared to ULXD, which actually makes for easier procurement across multiple regions, because you may find that the lower end is suitable for one region, whereas the higher range is suitable for the other in ULXD, whereas you could just buy one Axiom Digital system, which gives you a more common component inventory across your estates and therefore easier maintenance. You've got less spares. It would be pretty annoying to send a handheld in one tuning bandwidth as a spare to a system that's gone down in another one and find out, actually these 2 things are not compatible anyway.
That is indeed true.
Yep. And because it's wide tuning bandwidth, it's future-proof against future changes in spectrum. At the upper and the lower ends of the spectrum, we have seen a lot of sell-off. So we can no longer use it for radio mics. If you were to invest in ULXD at the upper range and it gets sold, then those devices become useless. And 2-tier transmitters for flexible system design.
Cool.
Let's take a very quick look here at the reason we're talking about Axiom Digital versus ULXD.
So that's a similar chart to the one I showed earlier, isn't it?
Yeah, so this is a spectrum availability chart from Ofcom for a location in London, which gives us guidance on which systems we should be choosing to use.
You've overlaid the AD and ULXD frequency bands showing which of those TV channels each system covers.
Yes, correct.
Gotcha.
So you can see there's a lot of overlap between the left and the right of the devices here. If I was choosing a system to use here, I'd probably go for the H51 band in the middle because that's the most appropriate. So I would be using in the ULXD H51 or just the wide tuning bandwidth AD. But if we were forced to or had some other reason to use channel 24 and therefore pushed us into the ULXD band, this is when it's going to start causing a problem, because we have a second office in Bristol whose wireless capability looks like this, and we are way, way more limited in which spectrum we can use. So had we chosen our ULXD G51 series, we simply would not be able to use that very reliably in Bristol.
Because the space is physically being taken up.
Yep. But we could happily have used Axiom Digital for both areas.
Gotcha. So we had a look at 3 chief systems right now.
Yep.
Lots of different applications. Let's just quickly round up the various comparisons between them to kind of figure out which ones couldn't work there. So we won't read the whole thing out in full detail, but you can see that MXW is chiefly suited to all of those things on that page there, particularly the self-managed area, as is AD to some extent, but ULXD would require a bit more input on that one. MXW is also license-free and also has the ability to remote control the transmitters, as does Axiom Digital. But again, that's the kind of system that really requires a tech on site to monitor it.
And then some ideal uses, of course, you can use any of these systems in almost any application, but there are some you should probably avoid.
Again, so I think this kind of, the MXWs for the smallest rooms, Axiom Digital in the biggest rooms, and ULXD kind of
somewhere in the middle.
Between the middle and chiefly.
There we go. And just a final little grid there. I've just noticed we are running a little short on time.
Yeah, so let's quickly whiz through the case studies, and I think we'll pretty much be there.
We'll take some questions. Yes, so just some nice pretty pictures. Here's a very large table doing video conferencing at the Doctors of British Columbia Association.
Yeah, and I suspect MX Wireless was chosen there because it's a multi-purpose space. They can change the space on a given day, hence the need to...
Lots of boundaries.
Yep. And the ability for techs need to just easily set the mics up on a daily basis.
Yep. We've got any given financial organization here with the guy at the front giving a presentation with his handheld. We can see on the tables there that somebody else would like to prefer to use a body pack, and we have some audience members with goosenecks on the table there. So here, goosenecks be the defining factor why you would not use Axient Digital.
Absolutely.
And we're probably expecting that the decked band was inappropriate because of other users.
Yeah, and ULXD works there well because it'll be in a fairly static environment, unlike the next one, which is the Stockholm Congress Centre. Of course, Congress Centres have different things, shows, events, all sorts of stuff going on a daily, sort of weekly, possibly monthly occasion. So here they have a whole bunch of, 2-channel racks, each with a 4-channel AD receiver in, because they're super resilient. They've got super tuning, easy wide tuning bandwidth. So they know, cool, that trade show stand needs 8 channels. We can supply them there.
Yep.
8 channels here, 4 channels there, and they know it's just going to work because it's so super reliable and rugged as well. And we also have a curveball.
We do have a curveball in many ways. Here we've got our Microflex complete wireless system, which is different to the rest in that it is a discussion system and not just a microphone system. So it's got its own little built-in loudspeakers.
So you can make your mic come out of there or other people's?
My mic will come out of everybody else's, and everybody else's will come out of mine, depending on who is talking at that given moment. And we said right at the beginning that 2.4 gigahertz was not the ideal range. Well, in certain aspects, when we're using like certain channels within the 2.4 and 5 gigahertz range, we can use it, and Microflex Wireless is very, very robust in that spectrum too.
Cool. Perfect.
Awesome. Should we take some questions?
Oh, should you quickly point to the resources? Oh. There's a quick resource to show. I'm going to show it on my laptop, Timo. So this is on the support website. We've got at Shure.com. So the first one is, this is the wireless frequency finder where I did the Beverly Hills scan earlier today. We've also got the wireless accessory wizard, and you'll check out the remote antenna tool, which is a nerdy thing for figuring out how long your cable can be. That's the antenna cable. And so let's have a look at this accessory wizard. I'm going to click on this one. And let's have a quick look at what kit we would need. So if you're beginning to figure out this stuff, it can be quite tricky. So I'm going to choose a ULXD dual or quad system, G50 band, that works for me. I'm going to use 6 devices, so 6 quad receivers would be 24 channels.
Yep.
I'm going to mount them in a rack like I've got behind me. Next, I'm going to remote the antennas, i.e. not put the antennas next to the kit, but run them on some cable into the room where the microphones are being used. It just makes the whole system work more reliably. And I know that the cable length is going to be somewhere in that 51 to 100 feet-ish of cable. And the antenna type I want to use, we haven't got the model numbers here, but I know that the wall-mounted one is a nice Wi-Fi access point.
Very similar to this.
Yeah, that's right. So just a very nice plain one that could be painted as well if you want to. So I've chosen my parameters there. I'm going to hit not reset, but submit. And it kindly points out to me, I would need, of course, 6 ULXDs, a wireless system which includes all the needed hardware, 1 distribution unit. We've not covered that, but basically that's a splitter for the single antenna feed to multiple units there.
And a wiring schematic.
Indeed, yeah. We can get the cable and also the boosters. And it also tells us that we need to set for that particular cable length these antennas to plus 10B of gain to compensate for any loss in the cable. So a pretty useful little tool there.
Yep.
Cool, so that pretty much rounds up what we wanted to show you. We're just on time, I think. So Cheryl, calling out to the US, are there any questions for us?
Awesome. Thank you so much, gents. So far, we just have one question, so I'll present that to you. And I know you kind of covered this, but maybe for anybody that missed it, this person is asking, where can I look to find the availability of spectrum in my region? This person is located in Texas, in El Paso in the United States.
Cool. I think, yeah, this web page, can you back to my screen, Timo? Let me go back a page. There we go. I've got it in full screen mode, so I've forgotten how to go back.
F11.
F11, there we go, F11, and then press the old back button. So what you need to use for Americas is this Shure wireless frequency finder. You'll be able to click on this, and then pop in your zip code and scroll down beyond this very pretty stuff. Is it loading? There we go. You'll be able to put your full address, city, state, or zip code in there, and it will tell you indicatively which TV channels should be free or busy in your particular area. You can also do some stuff in Wireless Workbench to figure out and explore rather which areas are there.
That's the best first port of call, though.
Yeah, I agree. Or you can call the US support team, and they'll happily be able to look at some other scans that other people have done in that particular region. So if in doubt for more specific information, just give us a shout and we'll put you in touch with the local team who will be able to figure out, or help you rather figure out which spectrum is available to you.
And just to add on to that, you can very easily open up a ticket with our support team, any support team across the world, by visiting shure.com/contact. That will take you specifically to the US form, but we can route them to the correct region and correct representatives. So shure.com/contact. We have a great team of engineers, applications engineers that can answer a wide range of questions across all sorts of audio topics. So, all right. Well, that wraps up our questions today. I think you guys must have really covered it soup to nuts. So great job. We want to thank you both for presenting today, and we want to thank everybody for joining us. We hope you learned a little something, and we hope to see you on the next one. Have a great day, everybody.
Cool. Thanks, everyone. Bye-bye.